Wireshark. It's a tool. It was formerly called Ethereal. It's a protocol analyzer, not a packet sniffer, but it is packaged with a packet sniffer. So Wireshark is a protocol analyzer. Don't trip that up. Everyone I ask thinks it's a protocol sniffer, but it's not. It's coupled with a packet sniffer called WinDump or TCP dump. The Wireshark itself is just a protocol analyzer, so it'll let you log packets through one of those things that it's packaged with. So it works on Windows and Linux. On Windows, it's packaged with something called WinDump for the packet sniffer. On Linux, out of the box, it comes with, if you install it on Linux, it'll come packaged with TCP dump. But understand, if you're in an industrial environment, it will not collect everything you see on the wire. So also this happens in Windows and Linux worlds as well. It does not capture all the management packets. We talked about this for the wireless. There's a lot of things that can't be forwarded over to the wired network. So just be aware of that it doesn't see everything. So there could be some limitations if you're really trying to look at some nasty stuff going on, or you know something's being transmitted but you just can't see it. Just be aware you may need to write your own protocol or packet sniffer, or go find a specialized one for whatever it is you're trying to look for. So the limitations of Wireshark are, all of these really, any kind of protocol analyzer, they're dependent on what protocols they know about and what the packet sniffers that are packaged with it feed it. So we talked about that, right? So insufficient for analyzing anything other than what it knows about. Remember, it's just a protocol analyzer. You need a filter to display packets with TCP, SYN, push, and reset flags set. So on the test, you're going to see a couple of things. Remember that it's a protocol analyzer, not a packet sniffer. Have that all over the place here. I've told you that many times in other slides as well. And also, how do you build filters in Wireshark? So you see where it says tcp.flags.syn equal 1, or remember the loafs we talked about, the logical operators for security. The tcp.flags.push equal 1. Notice the equal is the comparison equal, the double equal. You're not assigning it, you're comparing it. And there's another or, tcp.flags.reset equals 1. So this is what that would look like, that filter you're building. So how would you capture all TCP traffic going to or from 192.168.0.125 on port 25? That's a test question, which is actually a lie because it can't show you every packet because we just talked about the limits. But it will show you the ones that it understands. It'll also show you some that it may not understand, but not everything that was logged. So there could be more in the log A that you're not seeing, and there could be a lot more that was never logged in the first place from the packet capture utility that was packaged with the protocol analyzer of Wireshark. So tcp.port equals 25 and ip.host equals 192.168.0.125. So let me confuse you here, or try to. How to capture all TCP traffic going to or from this IP address on port 25. So tcp.port.25 and ip.host equals 192.168.0.125. So for the test, there's your answer. There's your filter. This is work on the test and in real life. So there's an excellent class that we have on Wireshark alone, so you can look for that. We'll also do a small lab on this as well and show you how to generate filters without having to know about them. You can just dig into the TCP traffic. You can right click and then create filter and it'll bring it up, and then you can kind of customize it from there. After you do that a few times, you can go through and start building your own filters. You can gaggle them together. It's a very powerful tool. So here's some of the, here's how it works. So you see the little blue square flag pointing down right below the fin there. And I started to type what was it? Flags.fin.push.reset. You see they're all there, SYN and urge. So you can see they're all there. And they just pop up out of context sensitivity. So it works pretty well to help you. It's very good at helping you figure out which flags you're trying to collect or which filters you're trying to build. So we talked about wireless hacking previously. Just an extra slide in here, ESSID for Extended Service Set Identifier. Previously we had talked about the SSID, the Service Set Identifier. Pretty much today they're all called ESSIDs. Just an evolution again over time, and this is what they're called today.